Okay, this one here is a trig integration, and um, if you looked on the formula sheet, let's go here down to this one here, you'll notice there is no cos and sine expression. Okay, and basically you don't think differentiation, we can do a product rule, that's differentiation. This is completely different. This is integration. So the trick here is to, as I put up here, use a trig identity. And basically what you have to do is go to your formula sheet, scroll to the last page, and what you're seeing here is this expression here. Let's make it a bit larger. We've got products, and basically you've got four aspects here. This one is sine A times cos B. Gives you, the proof is, you have to disbelieve this. If you have 2 times sine A cos B, you can rewrite it, see that equal sign, as this expression. Now here's the key. The right hand side here is very straightforward to integrate. This is not. You cannot easily, it's possible, integrate product trig terms. So this one here is cos A times sine B. This one is cos A times cos B, sine A times sine B. So you have to look at these options here and see which one fits. So this one here is cos 3x and sine x. So I'm thinking the second one here is what we need. So what does that mean is the A here is 3x. Now, basically, look what I've just done here. I've written out the trig identity, just confirm that. So cos A sine B is sine brackets A plus B minus sine A minus B. That's what I've just talked about right there. And obviously, I'm sort of going a bit more detail here. I'm saying let A equal 3x, let B equal to single x. So if that's the code, you look up here, you take this expression. Now, hello, this is a bit interesting. See that? That's an 8. That's a 2. So what's happened is I've factorized, excuse me, 8 to 4 times 2, taking the 4 out. So it's 4 times the integral of 2. Now that 2 matches up nicely, and we've got that matching up, we've got that matching up. Okay, then we're going to take this, replace this thing here with this. So basically what happens is that becomes, what's A? 3. 3 plus 1 is 4x, so sine 4x minus, because it's minus sine 3 minus 1 is 2, and there we have it. And what does the sign go to? A sign goes to a negative cos. So there's the negative right there. And what do? Divide by 4. And the same process here, that becomes, this bit here becomes negative cos 2x over 2. Now this is getting fiddly. We've got negative, negative, so that's going to give a positive. This 4 comes in and cancels out that. That's why there's only a 1 there. 4 times this gives you 4 over 2, gives you the 2. And that there, team, is your answer. And yes, I've put here in my notes here, this is fiddly. Now you could check that, okay? And if you did the algebra, out would pop this thing up here. Let's just jump down to this one here, number 113. And we've got a cos function, and just confirm what's a cos one look like. It's the one below it here. And we notice the pattern here too. So cos A cos B equals this expression. Interesting, you've got a plus there. Okay, just be careful. In theory, I should possibly write it out. In fact, I have done here. In fact, I'm saying use this relationship. And what happens with the 10? I'm seeing 2 here. So what can we do with 10? We can break it up into 5 times 2. Take out a 5. And that 2 bit is now there. So this here, trust me, is the same thing as this. And we're going to say A equals 5x, B equal, that's a dx there, 3x, and plug it into here. So this thing here can be rewritten as cos, what's this, 5 plus 3 is 8, plus, because it says plus here, 5 minus 3 is 2, and integrate cos goes to positive sine, divide by 8. Integrate cos 2x goes to sine 2x, divide by 2. Bring the 5s in. And there we have our answer. Oops, this way, yep.